grazing lawn is. So grazing lawns are short-statured mesic grassland communities that can withstand a very heavy grazing pressure. So grazing lawns generally consist of a continuous layer of seafoam grasses and ground vegetation, and they have a sparse distribution of trees and shrubs in between them. So the maintenance and the continued persistence of these lawns are mediated by both top-down and bottom-up controls. So by top-down controls, I mean things like grazing, fire, trampling, chicken, etc. And by bottom-up controls, I mean things like soil pH, soil nutrients, temperature, humidity, so on and so forth. So grazing lawns are found in a plethora of ecosystems and biogeographic zones throughout the globe. And the most famous ones being the ones in the African plains. I'm guessing we've all seen the huge herds of Cape Buffalo and wildebeest just mowing down on the short-statured grassland communities during the annual migrations. However, grazing lawns are found in all continents, albeit at a much smaller scale in the other continents other than Africa. So it's been found that grazing lawns generally tend to exist in a precipitation zone ranging from 400 millimeters to 900 millimeters. And here's a picture of what a grazing lawn looks like in my study area. So we can clearly see here that there's a continuous layer of grass underneath, and it's a very short stretch of grass. And in between we have trees and shrubs here and there. So why exactly am I looking at the effects of herbivore on grazing lawns? So one of the primary reasons is because grazing has a very profound impact on the vegetation structure of grassland and savanna ecosystems, and it also helps in establishing spatial heterogeneity in these systems. So they do this by two things. One is they uptake biomass from the grass, and they aid in nutrient cycling. So it's kind of like a positive feedback loop wherein they consume the grass and then they give back the nutrients to the soil by defecating in patches all over the grassland. So there have been numerous studies on grazing all over the globe for the past 4 or 5 decades. However, most effects of grazing have been found to be extremely localized. So, and they are also contingent on local environmental factors and the grazing history of the grassland patch that we are looking at. So it's quite important to look at the grazing effects of different communities across different geographic regions to come up with more generalized predictions and to manage and conserve these very sensitive ecosystems. We are employing a plant functional trait approach to look at the effects of grazing in our study area. So plant functional traits are plant characters that respond to dominant ecosystem changes, and community ecologists are increasingly using a plant functional trait approach because they're quite labile and sensitive to the abiotic and biotic pressures around them. And they also show a very quick response to the changes in their immediate environment. So I'm looking at soft traits in my study. Soft traits here mean traits that can be measured easily on field. For example, plant height or life history and so on and so forth. So plant functional traits are also used because they can easily be compared across communities, across biogeographic zones, so on and so forth, and hence they're a very objective predictor of ecosystem and community dynamics. So to address the effects of grazing on the grasslands of the study area, I'll be asking the following questions. What effect does grazing intensity have on plant species richness and species composition in the grazing grounds of XVII Tiger Reserve? And how does plant functional trait composition change along the gradient of grazing intensity? So the study was conducted in XVII Tiger Reserve in Tamil Nadu state, India. This is a map of the study area. The outline indicates the boundaries of the Tiger Reserve, and in the inside we have white patches which indicate the settlements or enclaves inside the reserve. And the yellow points here represent the sampling sites of my grassland. So I'll give you a brief tour of my grassland sites. Is it visible? So we're zooming into one of the grazing sites. So here we can clearly see that there's a continuous layer of grass underneath and there's sparsely distributed trees and shrubs in between. We also noticed that all of the grazing lands have a water source very close to them. So, for example, this is a perennial stream that is running right next to the grazing ground. It's not very near, I'm sorry. There are also ponds here, and these are all natural ponds. So, we observed that most of the grazing grounds tend to have a water source very close to them. And we also noticed that as we zoomed in, we noticed that there was lots of hill ranges across the landscape, and all the grazing grounds across the study area were present in the valleys of these hill ranges. So coming to the study design, we started off with a reconnaissance survey across the grasslands of Satamundra Tiger Reserve. So we did this to assess the viability of sampling. So we were basically looking at whether the grassland patch was large enough to accommodate a plot of 50 to 50 meters square, and we also checked whether the particular grassland patch had livestock or ambulance grazing, wild ambulance grazing. So after our reconnaissance survey, we ended up with selecting 18 sites in total. So we collected the following attributes from the sites. We calculated the area and the elevation of the site, and we also calculated the distance of the site to the nearest settlement. So within these sites, we had 25 plots in which we did a vegetation sampling, and we also had a dump ground survey to estimate the grazing intensity of the patch. And within these 25 plots, we had 300 subplots, wherein we looked at the species identity and the abundance. So this is what a subplot looks like. So to give you a visual representation of how I went about the vegetation sampling, this is one of my grazing sites. So here I plot a 15 to 50 meter plot, which looks something like this. We use ropes to demarcate the boundaries of the plots, and then within these plots we have 12 subplots which measure 1 into 1 meter square. We use a stratified random sampling approach to lay these subplots inside the plots, and we consider the spatial heterogeneity of the plots before we lay the subplots inside. So this is what a subplot looks like. We are looking at the species identity and the abundance of the respective species within this 1 by 1 meter plot. So after we did our vegetation sampling, we conducted the estimation of grazing intensity in the same plot. We did this by laying line transects. We had a total of 5 line transects, 1, 2, 3, 4, 5, and they were spaced 10 meters apart. So we started from one corner of the plot and then we moved in this fashion. We basically looked at the species identity of the pellet or dung group, and then we get a total count of the pellet or dung group according to the species. So once we had the dung count of a plot, we then converted that to angular density using a formula given by Pfeffer. So the formula is denoted here, where n is the number of pellets, A is the sample area of the plot, and T is the accumulation period of dung in base, and D is the replication rate of the species. So T and D were taken from a paper by Arashtani, and this was a paper which estimated angular density using dung counts in Nagarhode Tiger Reserve. So after we got the angular density, we converted that to angular biomass, and we did that because we do not just simply collect the densities of different species to get the grazing intensity of the patch. So we get the angular biomass by multiplying the density of a particular species. Here we have chital 5.79 kilometers into its mass 47 kilograms to give the total biomass of the particular species in a plot. So we did this for all species in the plot, and then we came up with the cumulative biomass of all species put together. So in essence, we had an angular biomass of a given plot. So, and then we went on to collect the functional traits of the plot. We collected a total of 3 traits: canopy structure, functional group, and life history. Canopy structure and functional group were recorded using field observations, and life history was collected using literature. So here in canopy structure, erect, crossed, and C-spiters. So erect here means species which are vertical or which have an upright form, and crossed species are species which have a horizontal or a mat-like formation. And C-spiters indicates grass species which are bunched together or have a tussock-like formation. These are also erect in form. So we use the following analytical methods to analyze our data. We use the linear mix model to test the effect of angular biomass, distance from settlement, and elevation as predictor variables on species richness, which was a response variable. So we use the plot identity as a random effect, and all the predictor variables were used as a fixed effect of the model. So we standardize all predictor variables before we went on to do the linear mix model. So to look at the effects, so look at the difference in species composition between the different plots across the Bayesian gradient. We use a non-metric multidimensional scaling NMDS for that. So we used a library group to cluster the points in our organization space, and the groups were based on a qualitative analysis that we made on field using parameters given by USDA. There were three groups that were made in priority. One was low grazing, indicated by 1, medium grazing, indicated by 2, and high grazing, indicated by 3. So, to just give you, to just show you how the different grazing sites look like in my study area. This is a low grazing site. We can see that there's a very high biomass in this particular grassland, and the grass height is also quite high, it's close to a meter. And contrast this with this, where the grassland has a virtually more appearance, and the grass height is very low, it's very close to the ground. So once we finished our NMDS, we then went on to do a trait composition analysis. So we calculated the trait composition of every plot across the grazing gradient to see if there was a change in trait frequency across the grazing gradient. We similarly looked at the functional richness and the functional evenness of all plots across the grazing gradient, and we checked whether there was any relationship between functional richness and evenness with angular biomass. So these are the results of our study. This is the result of our linear mix model. So we found that only angular biomass had a significant effect on species richness. It had a p-value of less than 0.5, and it had a slope value of 0.46. Distance to settlement and elevation did not have significant results on species richness. The marginal R-square of the model was 0.68, which meant that angular all the fixed effects explain 6.8% of the variation in species richness in the model. So this is a graph showing the linear mix model. The blue line represents the regression line of angular biomass, and the points represent the subplot species richness across the plots. So this is the result of our NMDS. So the points represent the 25 plots that we had across all grazing sites. The different plots are indicated by different symbols according to the grazing pressure. So one is indicated by squares, and 2 is indicated by triangles, and 3 is indicated by triangles. So we see here that groups 1 and 2 have a very high overlap. But there's a stark contrast in composition between the first two groups and the third group. So this might indicate that for species compositional difference to be noticeable, the grazing pressure needs to be very high. So the results of our trait composition was as follows. So this is a graph representing the canopy structure. The x-axis are sites or plots arranged according to increasing order of their biomass, and the y is the proportion of traits of erect and cross-tail. So we see here that erect species are more proportionate in most of our plots. So we found no relationship between canopy structure traits and angular biomass. Similarly, light density is also indicated by x-axis, which is plots arranged according to their increasing angular biomass, and y again is the proportion of annuals and perennials. Here we see that perennials are more proportionate in most of the plots. So again, we do not find any relationship between light density traits and angular biomass. So the functional diversity results were as follows. We found that angular biomass has a significant effect on functional richness. It has a p-value of less than 0.05. and the slope value was 0.55. The adjusted R square was close to 0.2, which means that the angular parameters shows a 20% variance in functional richness. The model here shows the linear regression line of angular parameters, and the points represent the functional richness of the plots across the grazing gradient. So for functional evenness, we saw that angular parameters has a significant effect on functional evenness with a p-value of less than 0.05, and the adjusted R square value was 0.13, which means that angular parameters showed a 13% effect on functional evenness. The model here represents the regression line of angular parameters, and the points represent the functional evenness of the plots across the grazing gradient. So in conclusion, we found that grazing intensity has a significant but a very marginal effect on species richness of the grazing lands in the study area. And again, we also found that grazing pressure has an effect on species composition, but the difference in composition is only noticeable when the grazing pressure is very high. The third point was that grazing intensity does not have any noticeable effect on the trait composition of the traits that were examined in the study. And the fourth point was grazing intensity influences functional diversity, wherein functional richness increases with increase in biomass and functional evenness decreases with increase in biomass. So, as a way forward, we would like to look at the effects of soil properties and precipitation on species richness and composition of grazing lands. This is because we found that the plot identity of the plot attributes accounted for most of the variance in the linear mixed model. It would also be interesting to look at the differential effect of livestock and ungulates. In this study, we looked at the effects of livestock and ungulates put together. So, it would be interesting to look at their effects independently. Grazing, the species composition in grazing lands. I would like to thank the following people without whom the dissertation would not be possible. In particular, I'd like to thank my supervisor, Dr. Rajapali, Dr. Narendra Page, and Dr. K. Ramesh for their constant support throughout the dissertation, who was a great companion during field and who helped me a lot in my fieldwork. All the WI faculty who taught us a lot, and all of my batchmates who all went through a very tough time during COVID, we still persevered, and we all did a great job, I feel. And for my parents, for their constant love and support, thank you. I'm open to all questions and suggestions. Any questions?
Good presentation. Some of the very interesting findings. I have one question and two comments. I was wondering if these kind of studies have ever been conducted in this area. Okay. Second thing is that when you talk about the herbivores, I think we should regard it as hobbits. Raising by house buffaloes or dog, raising by goat, sheep, and maybe chicken, or raising and crossing by sambar, there will be different type of herbivores. So the effects on the species composition and biomass will change. For example, the area raised 21,000 buffaloes will have a totally different community because of their feeding habits. I wonder whether you could look into this. This is one. The second question is, you think the role of fire, the issue of fire in the area, we don't know only rainfall now, but wondering whether fire also was possible. If so, do you think there will be any changes to that?
So yes, so the first question was to look at the effects of different ungulates and servants and things like that. Right? So we tried, but that wasn't really possible because we use guns to estimate the angular density. And all of the grazing patches had grazings from all kinds of species. So it was difficult to like pinpoint if this particular group is here or not. So that was one thing, but yes, if we probably deploy camera traps and use other methods, we could probably address this particular problem that you are asking. And regarding the second point, fire, we did ask the local field staff about the history of fire. And as far as I know, the sites that I've sampled did not have any history of fire. But the history of fire was not very accurate. For the past 2-3 years, they could tell us, but beyond the 2-3 years, they were not able to ascertain the impact of fire. But yes, that would definitely have a very huge impact on these grassland communities.
Okay. One of the important images you have considered, one can easily figure out that if you see that it is a blue and one
Sorry, I'm not very audible, sir. I can't hear
Hello, can you hear me now?
you. Yeah.
Okay, what I want to make the point is that you have used a strong images that one as an indicator of physics. In the literature, nowhere has been used where the animal has to raise based on the people. This is a very, very strong image you have used. You can use what scalability and what is site where they have reached. Because animals have raised one point. And it could be gradient successor constant. The role of Vega Hunter is a very, very important component.
Yes.
I don't see any true gradient in this where there is a Vega Hunter and the gradient. Okay. So this is another artifact I don't know how you would like to because in the water, there are a lot of soil ecosystem to control. When the high gradient pressure into the water, the water, so you can say between a high gradient the low density, a high gradient the high density. High gradient would be about D component, I don't know how you integrate in your
So regarding the large herbivores, we have
look at the indicator of the gradient.
so like we conducted dump count in the plots that we conducted vegetation sampling also. So we basically look at the grazing pressure of those particular plots. But as you look at a solid point, I understand your concern. Grazers do not definitely graze at the same point where they defecate. That is understandable. But these grassland patches are not very large. They're from they range from a size of 1 hectare to around 15 hectares at most. So I'm guessing that the grazers are grazing within those grasslands. So since the plots are randomly placed, I'm guessing they're capturing some of the grazing intensity using the landmarks. And regarding the large herbivore presence, there is presence of deer, there is presence of cattle, and there is presence of elephants. So all of these have been known to uh, known to initiate the formation of grazing lands. But large herbivores are not the only reasons why grazing lands are formed. There are a lot of other reasons. We have things like solid sites or concentrated sites where animals gather because there are also resources in that particular area. So there are umpteen number of other reasons, and we do not really know how grazing lands are initiated. So it has been found in the African context that yes, there are certain large herbivores which initiate the grazing land complex, like rhinos and cave buffaloes. But in other ecosystems, in other continents, it hasn't really been explored as much. So we do not really have an idea of how the formation of these grazing lands come about. So it's very hard to tell if it's actually larger herbivores who are initiating the formation of these grazing lands. So I can't hear you. It's not.
Point of is the soil texture, the soil characteristic, which is a major component. It looks a lot of work it came from the Johnson chart.
Yes. So
Yeah, that's the one of
we
the.
looked at the soil components, but we couldn't analyze them in time because of COVID, so we have not included that in the study.
Aloha, yeah, great presentation, nice work. A couple of questions like the first question is there any difference between the proposal which you put while you were defending your initial thesis and the outcomes you are showing here? Is there any difference?
Yes, definitely. So during the proposal, I broadly looked at the effects of grazing on grassland based on literature, wherein it showed that species composition generally increases and has a mid disturbance peak. But that did not happen with our study area because grazing lands are generally formed as a history of very long grazing pressure. So grazing did not have a very high effect on the grassland communities in our study area. So that was one thing that I found. So yes, there were definitely changes between the proposal.
Yeah, because why I am asking this particular question is if at your initial stage, you had come and talked to us about using dung as a come as a major to the abundance. I think probably 90% of the people would have opposed that particular idea, especially considering the location of your grazing grounds, the presence of the water holes. There's a 90% possibility that most of these animals are just going drinking water, defecating there and coming back. So no effect of grazing at all. Probably you may visualize this as a grazing effect. And then it would have been very easy if you have not done count, but just spend a day or 2 days and said what proportion of animals are going for a water hole and what proportion of the animals are staying in and grazing. And that would have answered most of the questions what people are asking, whether it's animals coming and going. And if you have used like, since these areas are very small, you could have used a total count.
We did that, we did that visually.
So you can if you have that particular information, you can plug in that particular information and see the number of species. And then other important aspect is when you again talk with this dung defecation rate. Defecation rate is a 24-hour cycle.
Yeah.
Okay. But you are looking at a very small patch. So your animal is not there for 24 hours. So the one animal will come, other will go, other will come, and go. So people use defecation rate, but then they consider that they have sampled the entire area. None of these animals are out of that particular area when they convert this to the abundance. So when you convert your figures to the abundance, so it's probably is out of the place. So it doesn't reflect that particular abundance because you have a very small sample area which is there. I think you need to correct for that also. And and then very interesting aspects is with this with respect to grazing ones is the slope aspect and terrain of these grazing ones. Slope aspect and terrain. Because within these grazing ones, there can be what we call as a seed banks. So what seed banks may be there somewhere, and these seed banks may be responsible for the dispersal of the seeds during the germination period. So if you even if it's a very small, but the terrain is undulating, it can sustain multiple seed banks, which can impact the diversity of the species. So whether it's actually the effect of the grazing, or it's the terrain or the slope where this particular grazing land which influences the production of the seeds and then subsequent germination. I think if you just visualize this particular aspect, and probably you will get a better effect. And while looking at your regression, R square value of 20%, if you remove the last 4 points, okay, probably your regression line will be flat. So whether it's a real effect of the grazing or something else. So when you are just working for your for your publication, try to look into these particular aspects in the past.
So I don't see anything in the online YouTube in question here. So I guess if there's no more question, then if Arwa has in hand and please Kapoor to come.
Good morning, everyone. Today I'm going to talk about something which we generally see daily and we ignore them a lot. That is ants. I like ants because of the unique caste system they have and the role they play in ecosystems. Like they are predators, they are herbivores, they are decomposers, and they do a lot of things in the ecosystem. So I decided on to walk the trail along with the ants for my dissertation. As we all know that human-made changes has been called known to lead to loss of biodiversity, be it in any sort of ecosystems. And ants are no exception. They are also affected by these changes. And how did these ants have been responding to these changes in if you see the land use change, ants have been shown to respond by reduction in species richness, change in their abundances, or change in their composition, which can happen either by the loss of specialist species or proliferation of generalist and trans species. But traditional agroforestry systems like native shaded coffee plantations have been shown to act as refuge for biodiversity in an otherwise inhospitable landscape. And few studies from India have investigated the effect of fragmentation and land use change on ants. So, with this background, I went on to look at the richness and compositional differences or responses of ants to land use change. I started with the aim to determine the effect of land use change on ant communities. So, I asked the specific question: how does ant species richness vary across different land use types? And how does ant community composition vary across different land use types? So the different land use types considered for this study are the contiguous forest, forest fragment, and coffee plantation, which are further of two types. The native shade coffee plantations, which retain the native tree cover of the region, and exotic shaded coffee plantations, which are predominantly dominated by silver oak. I hypothesized that uh, across these land use types, there is a reduction in structural complexity from forest to coffee plantations. So I hypothesized that the species richness will also decrease along this gradient, and so does the species composition change. So I got a perfect study area in form of Kodagu in Karnataka, which lies in Western Ghats and also has a lot of coffee plantations, and it's a highly fragmented landscape, giving me all those land use types together. So I have sampled. So yeah, this is how it looks like. The hill slopes being occupied by coffee plantations, and the valleys with paddy, and fragments here and there. And these are all preserved in form of sacred groves because of the religious beliefs. So it is I have total 11 sites sampled across all the land use types, and at each site I have 4 transects. Each transect having 60 meters in length. 60 meters in length. For checking out the structural complexity of the vegetation, I compiled data from a previous study and also collected data from some of the sites. For getting data related trees, I had a 10 by 60 meters belt transect, and at the start and end of the transect, I had a 5 by 5 meter subplot for shrubs, and along the transect at 4 points, I gathered the information on leaf litter amount and canopy. And I sampled ants following ants of leaf litter protocol, and ants were sampled along the same transect where I gathered the vegetation data. And I paired the pitfall trap and wrinkler extraction together and forming a sample, and each sample was spaced 20 meters apart along the 60-meter transect. So each pitfall trap is essentially a paper cup filled up with detergent solution like Surf Excel and was left active for 24 hours. And leaf litter extraction is a modified form of wrinkler extraction where I gathered the leaf litter in a sieve, and the sieve was actively searched for ants from a point-per-meter quadrant. And the thus collected ants were sorted and identified in genus level and was given a morphospecies number. And only worker cache was used for identification and for the analysis. So for differences in species richness, I plotted observed species richness at different scales like sample, transect, and land use. And I used estimated verified species richness at land use category. I estimated the beta diversity, and I ran linear mixed effect models to check out how different habitat variables are explaining observed species. For species composition, I ran non-metric multidimensional scaling, and I had this analysis of similarity to check out how different communities are varying across land use types. So coming to structural complexity of vegetation, the first I have few measures: the canopy closure decreased from forest to coffee plantation, and which can be seen from some of these photographs, fragmented coffee plantations, how the canopy opens up. Because coffee is a shade demanding species, canopy is generally cleared up. And the leaf litter also decreases from forest to coffee plantations. This is point-per-meter quadrant. And this could be attributed to the opening of canopy and also regular clearing of leaf litter in coffee plantations as part of the management practice. And the tree basal area increased slightly from forest to fragments and coffee plantation, native coffee, but it was lowest in silver sheet coffee. But along with that, the standard diversity of height and girth classes of trees didn't show any particular trend. And in conclusion, all of these land use types varied in the vegetation structural complexity. Some of the measures decreased and some of the measures didn't show any clear trend. So this is just a contrast between a fragment and the coffee. Here you can see clearly the lowest layer in coffee plantation is entirely replaced with just a single layer of coffee. So I got around 70 species of ants from 31 genera, and subfamily Vignesia was the highest subfamily represented with 29 species, and leptogenous genera was the genera which is most specious, and Nylandria species 1 was the most abundant species collected in a lot of the big photographs. So coming to the results, the observed species richness, the average richness was the land use at samples. So it showed a decrease in trend from forest to silver shade. As expected, this trend was expected. And so does the trend shown at transects. So at samples and transects, there was a steady decrease from forest to coffee plantation in average species richness. But interestingly, here the trend disappears at site scale and reverses at coffee plantation. At land use scale, the forest was having least number of species, and coffee plantations were having the highest number of species. And before entering further, I would like to explain this concept of beta diversity here. I used the bracket beta, which is calculated by gamma upon alpha, the overall land richness of the area, and then by mean richness of sites. So the beta diversity will be 3. And another 3 case scenarios, like case A, where increasing sampling of new sites, you get addition of new species. That represents a case of spatial turnover. And in case 2, here with the increase of site sample, there is no increase in species overall richness, but essentially each of these sites are subsets of the original first site. And in scenario 3, there is both subsetting and new species getting added. So this represents a case of turnover and nestedness. But if you just look at the beta diversity values here, it's similar. So it indeed is important to differentiate the beta diversity into its components of turnover and nestedness. So when coming back to beta diversity, I found a steady increase in from forest to coffee plantation. What does that mean? So if you take 2 transects in silver shade, they are more likely to be dissimilar when compared to 2 transects in forest. So is the case across sites also. And when you partition the beta diversity into components of nestedness and replacement, so the contribution by replacement increases from forest to silver shade, which might be the reason I am seeing a lot of species in coffee plantations when compared to forest and land use scale. when I ran linear mixed effect models with observed species difference as response variable and transects as random effects, I used the structural variables along with I included two other variables of insecticide and human habitation. Because some of those coffee plantations were having insecticide use and a lot of these sites have human habitations in them which have been known to affect species richness either through increase or decrease in species. So the best model was with the stem density and the human habitation. The best model explained very little variation. The marginal upscale was 0.06, that means 6.5% of the variation. Although the best model was within 2 delta AC units of the intersect learning model, which essentially speaks out that this best model might not be different from the intersect learning model. So, in conclusion from this slide, none of the habitat variables explain the observed species richness in this study. Coming to the species composition part, 8.6% of the species were shared across all the land use types, and coffee plantations shared 37% of the species between themselves. And coffee plantations put together shared 56% of the species with forest and fragments put together. This index says that how much species these coffee plantations are having from the original landscape of forests and fragments. So when I tried looking at the composition, the analysis showed that the forest communities might be forming a distinct cluster. So I ran an analysis. So an analysis of similarity showed that the overall composition might not vary across all the land use put together, but the forested landscape and the non-forested landscape, the coffee plantations and fragments kept together, showed a slight variation, where the R square was 0.1. So where does this study stand in the global context? So a similar study from the WA in Karnataka with coffee plantations has shown that they found that there was no richness differences between forest and coffee. But Indian my study found there was an increase from forest to coffee plantations. And globally, majority of the studies which have did conversion of forest to plantation studies, they have found that there is a decrease at both the transect scale and land use scale in number of species. And there's just one study which I came across that reported the scale dependency of species, which I also encountered as part of our study. Summarizing it, vegetation structural heterogeneity varied from forest to coffee plantations, and species richness decreased from forest to coffee plantations at transect scale, but interestingly reversed at land use scale. Beta diversity also increased from forest to coffee plantations, but with an increased contribution by replacement in coffee plantations. Although forests has distinct communities, there is no significant difference in overall communities across all the land use types. So some other interesting observations from my field work is species with morphological adaptations to drier conditions like Meronopus species were found only in coffee plantations. Like which might indicate that the temperatures in the coffee plantation much more higher with the opening of canopies. And exclusive leaf-related dwelling species like Scumigenus were reported primarily from forests and fragments, indicating that leaf-litter as a microhabitat might not be available in coffee plantations. And rarer genera like Discosydium, Wilmotaurus, and invasive species like yellow crazy ant was reported only in coffee plantations, which highlights the importance of coffee plantations in maintaining the overall biodiversity of the landscape. So, in the future, I would like to add other dimensions of diversity, like functional diversity and phylogenetic diversity, to explain these richness pattern observed, and also include the arbor land communities, as these might be directly affected by the vegetation characteristics, as the competition for resources or nesting sites. I would like to thank myself for coming up to the stage and doing this. I'm a parent for the love and support, and all the aunties were generously donating all their daughters and sons. And director, dean, the post directors, and all the faculty who had nurtured me here, my PS, Gautam sir and Ravindra sir, and Dr. Kushlappa, Devagoda and Satish for the field support, and Dr. Sumanta Bakshi and Pranay Bajaj for their help in ISC regarding the lab work, and Pankaj Bhai, Bhavnaji and Poonamji for all their help during the lockdown, and Poonamji for especially for this painting, and all my batchmates for everything in these 2 years, and my batch, starting from my batches, Dr. Michael Legan, Kalan Kumar, and my co friends, the Karnataka Forest Department for giving me permission to collect all these ant specimens, and Negi ji for all his help, and God for his grace and support. And thank you for joining me on this journey with ants. And for your information, this thing is not an ant, the other ant. This is just an earthworm, Arborean earthworm found in the domain of a plant, a commercial business. It's found in Western Ghana. Thank you.
Thanks a lot, Prabhu, for speaking well within time. So, if you have questions,
Shakur, a very good presentation, very nice work. Uh, if I remember, or even if you remember my question when you were defending the proposal, I think I have to go back to the same question. That define a landscape for the ant. Because the ants which are present in my home, inside my house, are different than the ants in the land outside my house. So I think when we are talking about the diversity, when we are talking the composition, when we are talking the richness, what's the landscape which we are talking about? Okay, and how we define that particular landscape, right? So that's like how you have come across, like there is a variation, like in terms of a community structure or in terms of a richness from one species, one particular aspect, other particular aspect. So I have not seen anything you talking about the area sample in these particular different habitats. How far was this area from, what was the number of plots which were close to the forest edge? What were the number of plots? When you have sampled your plots, then should be the distance from the edge, distance from any other habitat type, distance from any unique features in that particular landscape, because these are the parameters which are going to influence the species richness or community structure of the ants in a particular landscape. Considering that, like we know that like history study, how far we can go, where we can offer. And then third important aspect which I would have visualized is the presence of less number of species or the specialized species not found in coffee plantations. Is it because of the leaf litter or is it because of the use of the pesticides in these coffee plantations? So, like if or what type of species then come in these coffee plantations which are resistant to the use of the pesticides? Then in the coffee plantations, and also like I don't know much about the ants, but we have one guest faculty who came here from, I think, from the university or somewhere to give a talk on ants. So he also talked about a lot of invasive species, probably in ants they call them trump species. So, was there any such species in our area, coffee plantation versus other plantations? And if there were trump species present, was there any effect on the native species richness or community structure with respect to the presence of these trump species?
So I will just start up with from backwards the question about the trans species. I found trans species or this Endocritian, which is an essential invasive species, which was found only in the coffee plantation. I really didn't check for the effect of this species on other ant communities as such. But this species, I mean, studies generally have found that these ant communities, since because they are found in huge numbers, they can grow up in huge numbers and can might exert effect on the other ant species that are generally in low in terms of their colony size and they are having specific diet specifications. These are very general. They tend to fit, they come there act as scavengers and whatever. So I really did check the effect of this specific species on other species. And coming up to the question on, uh, yeah, I didn't say how many sites I had. So I had like 3 sites for 3 fragments and four native shade coffee plantations, 2 silver oak plantations, and 2 forest sites. So overall, I had 11 sites, and transects were made in such a manner, and all of these sites were in the size class of 8 to 10 hectares, except for those forest sites, though. And although these sites are spread out in the landscape, all the landscape matrix variables like what is adjacent to the coffee plantation of the fractal were essentially same, because like every site has a road nearby to it and its coffee and its paddy road. But I really didn't check the quality of all the sites. And transects were made in such a was made randomly across the site so that they are spread out. So I really didn't check out the effect of edge as well, but some of the transects extend up till the ended up at the edge, some were in the interior, some were not in the interior or the edge, like lying in between also. And they are defining landscape for ant question. Which I don't think I might be able to answer it now. I'll try to answer it later.
Yeah, it's a nice question. Yes, sir.
Like I
I have one question. We will try to look the nutrient extraction capabilities. Okay, so this or probably some of the countries information what nutrients are. Second question, I presume that these are species that are very sensitive to the microbiome. And I expect to have a, what it is called the ability coastal richness. So any species one more thermal problem. This ability coastal richness of the species like all are functionally similar.
So coming up to this question, second question. So that was part of my second objective in my proposal, which I couldn't do because I couldn't continue the lab work in ISC because of the lockdown and corona issues, which I will definitely try to do it in the later part after this is done. And I hope to find some differences. And the microhabitat requirements and all, I took measures of soil, temperature, and moisture level, which are known to influence ant species stress. But I really couldn't analyze the data because of time and other variables that were affected during the sampling period. Like the transects were laid from morning 10 to 12. And from all this duration, I used to measure hazard variables whenever I was playing a quick podcast. So during this time, let's say I'm measuring the temperature of the soil. So it varied across the day. And that is some of the days were really raining, some of the days were really sunny. So I didn't have a control for that. So I really don't want it to include that also. So that's why I didn't include all these in the analysis, temperature and moisture levels.
So suppose there's a question from Manpreet Singh, I'm just going to read it out, okay? He says, in the initial slides you mentioned about determining impact of land use change on ant communities. However, he's skeptical that you are actually able to do so because the effect of land use change over the years wasn't examined. So you don't have the historical data on how the land use has changed. Because land use type and land use change are different and can be used interchangeably, what you said.
So I'm looking at the effect of changing land use as such over time, but I just have looked at a time frame, or like a snapshot of the land use change, land use type, with snapshot see how these companies are varying with land use. So if it's possible in future, try to do it with the change, how the companies will change. Thank you. Ma'am. That is further. Yeah.
Okay, so I'm just curious, you said the richness in decrease as you move away from coffee plantation, is that what you said?
No. So from forest to coffee plantations, the richness decreases. So forest has the highest richness. Let's say the transects can bring up transects. So forest has the highest richness at transect, and coffee plantations had lower species and plantings.
I wanted to ask you, if you compare similar habitats across the world, is that the natural level of distribution that you find? Is that what how to explain?
That thing I haven't done, but I don't think that's it. That will be a real good measure uh, because the local richness also matters, right? Like if you go away from tropics to temperate regions, the local species richness will decrease. Probably we will have to look at the magnitude of change.
Yeah, that is why falling upon Wallace's question, there are some question also. The scale and the micro habitat really matters, and it doesn't seem like you use that as a measure to look at distance as well. So, what do you plan to replace that?
So I would like to look at for the micro habitat variables which are collected and try to see if I can use them properly to incorporate and then try to use them to explain the pattern which I got.
Yeah. So there's a question from Rohit Jha. He's asking if you compare organic and non-organic coffee plantations for differences in species.
Not really. I hadn't classified them as organic and non-organic because, and especially the insecticide part, that was the data was gathered by talking with the coffee plantation owners and as part of my field study, field observations. Because a lot of these coffee plantations that was picking season, they use insecticides so that they don't get attacked by camptogaster and beaver ants because they are present on the coffee and they nest in the coffee trees. So I haven't really done it, but I use those their use or whether they're using it or not. And I really didn't find any difference when I did the analysis. Really didn't find any impact of insecticide in my in the coffee plantation. But the study has shown that in the same landscape, the insecticide usage has reduced the species richness. But the reason could be due to the method of applying of insecticide or the amount of insecticide that is applied in a study, which is generally dusted on the coffee beans, which I too have seen them. But from the other few coffee plantations which I had several just have come across, they spread out the insecticide as a like white sheet on the whole ground. So you can't see the ground at all, it's just completely white. So those coffee plantations might really reduce the species.
Good, can you hear me? Awesome. It was a very nice presentation. I just was curious to ask about the differences of diversity, between crops of a particular type. For example, forest, or tree, if you see any sort of differences between those sites, within which subclass of site which you are sort of classified, what's the diversity of
Yeah, I mean,
some of the sites show whereabouts are very, very high. Sites are very whereabouts are very small. And there's a number of sites who actually have a lot of variability. So the next question would be what causes that variability? See, there's like things that are not very site or very fixed. You get the question.
yeah. Can you just repeat the question again?
So the first part was how much availability you see within these class or sites you should categorize, right? That is one. And some sites are little bit of high availability, forests may have high availability depending on the sort of plot you selecting. I think for that you lay a forest, say you laid it on the forest that was you laid it on a forest that was much deeper inside, or a forest that was less isolated, or larger chunk of forest. So I mean, how do you capture that variability? How do you account for that variability?
So the variability was highest in, let's say, was in both forest and native shade coffee plantation. Because in native shade coffee plantation, there was one site which had just 17 species, and the other remaining sites were like having around 26, 27 species. So few sites, few like even forest had real low, one side is high number, one side was very low number. So there are few sites which where there is a higher variability, and some of these sites were not having that much higher variability. Also.
Comment. I only comment is that why we look into one aspect monitor. It explains some of the patterns that you are seeing better.
Yeah.
It's maybe something that has sort of you can interpret this way or that way. But overall, I think it's excellent.
Thank you. I will look at it.
If there's no more questions, let's give the floor to hand. And we welcome Anjita for the Thank you.
Very good morning to all. We all are very proud that India is one of the richest biodiversity countries in the world. With its two biodiversity hotspots, the Western Ghats and the Himalayas. Western Ghats especially is very rich in biodiversity because of its unique habitats and high intimacy. But Western Ghats, like other parts of the country, is subjected to extreme environmental degradation, habitat modification, habitat fragmentation, and language changes. Especially the southern Western Ghats. There, one of the major reasons for environmental degradation is the conversion of forest lands for commercial plantations. This is an image from the Muna region of Idukki district of Kerala. Here the plantations has caused severe, um, it has caused severe landscape, sorry, habitat fragmentation in the Shola forest. These plantations were established by the British government in the late 1800s, and now they are under the Canadian Hills plantations. This kind of habitat modifications can have very negative influence on the animals, and there are a lot of studies that also have been done on the animals, but most of the studies were focused on larger animals like elephants and tigers whose home ranges are large. But when it comes to smaller animals like this, like reptiles, especially the lizards, there are only very few studies are done on this aspect. Some studies shows that if there are two populations of the same species in the modified and the unmodified habitat, there can be differences in the body condition, morphology, escape behavior, etc. of the lizard in the two different habitats. One study done by Deepak and Vasudevan in 2008 from Wildlife Institute of India has found that the density of the Anmaris Panivisar Salia and Malayana in Iravaram National Park is almost the same in the modified habitat, that is tea plantations, and the unmodified solar forest. So it was interesting to find if the tea plantations is the modified habitat and was established around 100 years back, if it has an influence on the lizard. So we chose Salia anhalayana as a model organism to study the effect of habitat modification on lizards. With this, I come to my topic. One may decide in a mosaic landscape the effect of tea plantations on Anmaris Valley lizard. The study was supervised by Dr. C. Ramesh, Dr. Abhijit Das, and Dr. Deepak Tiwari. Salia anhalayana is an endemic agamic lizard of southern West Bengal, south of Pathat Gap. It is a high elevation species which is found above 1500 meters above mean sea level up to 2500 meters. It is an insectivorous arboreal lizard which is active during the day.
March and April. It is a spectacularly ornamented lizard, and it also exhibits sexual dimorphism. The males can be differentiated by their spines in the dorsal side, which extends till the tail. And the females, which are smaller in size, do not have the spines in the dorsal side, and the juveniles can be easily identified because of their smaller size. The aim of the study is to find the effect of habitat modification on morphology, population, and habitat association in the lizard. I come to the objectives. The first objective is to study the effect of modified habitat on body condition, sex ratio, and thermal profiling of the animal spiny lizard. Second objective, to determine the factors influencing density of animal spiny lizard across a disturbance gradient. The third objective is to determine the basket microhabitat use of the lizard in the modified and the unmodified habitats. And the final objective is to determine the effect of habitat modification on the escape behavior. We have chosen our study area as the Yellowstone National Park and the surrounding solar forest and the tea plantations. The Yellowstone National Park is very famous for its grassland solar ecosystem, which is undisturbed and highly protected inside the national park. Outside the national park, there are some solar forests, which is coming under the territorial division of Mona. These solar forests are found very close to the tea plantations and are also disturbed. The tea plantations is found in the surrounding areas. So these three are the major habitats we used to be selected for our study. The field survey was conducted from 31st January 2021 to 27 April 2021. Line transfer methodology was used to estimate the density of the lizard and diagonal visual encounter surveys for testing other hypotheses. Vegetation sampling was conducted for habitat characterization. And the survey was done from 9 a.m. to 2 in the afternoon because the lizard was found to be more active during this time period and the sighting was also high during this time period. We used the software R and distance for statistical analysis. During the visual encounter survey, we sighted the lizard, and if the lizard was sighted at a distance more than 5 meters, we used an NB touch height. If it is less than 2 meters, we measure the flight initiation distance, and after that we caught the lizard and did the morphological measurements and also collected the habitat use variables. We all know that the solar forest and the plantations are very different from the photo itself, but how much are they different? To find that we did vegetation sampling, we took a plot of 10 by 10 meters, and inside that we counted the number of trees and measured the height and leverage of the trees. And we also took 5 by 5 meter plots, and inside that we measured the number of shrubs and liana. And in 1 by 1 meter, we collected data on hair density, grass cover, and leaf cover. The data was analyzed using principal component analysis, and it shows that these two habitats are very different because there is no overlap between the two circles in the graph. The tea plants in the plantation were considered as shrubs, and in the tea plantations there were shade trees which were periodically grown. So the characteristics of the tea plantation was high shrub density and tree pruning, and in the solar forest was characterized by high canopy cover, high tree number, high herb density, liana number, high grass percentage, and leaf percentage. Total we have cited 160 individuals, and out of that 87.5% were adults, 4.4% sub-adults, and 1.3% juveniles. For 6.8% of individuals, we could not identify the age class. The study was conducted during the rainy season of this lizard. Maybe that is one of the reasons for the large sightings of adults. We also conveyed the sex, and we found that out of 160 individuals, 75% of the individuals were males and only 16.3% of the individuals were females. Using this data, we also calculated the sex ratio modified habitat, that is plantation, it is only 14 females for 100 males. When it comes to Shola coastal plantation, it improves to 33 females per 100 males, and Shola away from the plantation, which is inside the protected area and which is undisturbed, the sex ratio increases to 50 females per 100 males. The sex ratio can be considered as one of the indications for the health of the population. This high sex ratio is good for the population. The male bias sex ratios can cause increased male aggressions. And there is one more thing that the study was conducted during the breeding season, and also the males are highly ornamented and larger in size, so there may be chances that the detection probability of the males was high. But we didn't do any study based on that. Even if the detection probability of males was high during this time period, the study was conducted in the same time period in all the three habitats, so the comparison is not affected. Coming to density estimation, which is one of the major objectives of this study. We use line transfer methodology for density estimation. We rate 100-meter transfers, 35 transfers in plantations, and 22 transfers in Shola forest. We did 3 to 5 temporary replicates in each transfer, and the data was analyzed using distance software. This shows the distribution of transfers in Shola and plantations. The yellow dots indicate transfers in Shola, and red dots indicate transfers in plantations. The Shola, as mentioned earlier, was classified into Shola coastal plantations and the Shola away from the plantations, and the density was calculated separately for each habitat. And it was found that the density of the lizard is less in plantations, which is the modified habitat, compared to Shola coastal plantations and Shola away from the plantations. The high density of lizards in the Shola coastal plantations might have caused high competition in that area. The reason for low density of the lizard in plantations will be further discussed in the further slides. We also classify plantations according to the proximity to Shola. Plantations which are 15-300 meters from Shola and plantations which are 300 to 600 meters from Shola. And it was found that the density is influenced by the proximity to Shola. Since the plantations which are close to the Shola have higher density of lizard compared to plantations which are away from the Shola. We also classified plantations based on the presence of shellfish, and it was found that the lizard was found only in plantations with shellfish. So it clearly says there is a preference for shellfish in plantations for the lizard. Coming to the body condition and morphology, we compare the body condition of the males between the habitats, and it was found that the body condition of the males is significantly higher in Shola away from the plantation compared to other two habitats. Body condition is defined as the ratio of mass to width south to wetland. It is an indication of the health of the lizard. When the body condition is high, the lizard is more fatter and it has positive influence on the survival and reproduction of the lizard. When the lizards are in modified habitats, they more often become they more often encounter potential predators, and the frequency that they have to feed on the predators will be high. So there will be more consumption of energy, and it can also compromise their foraging. So that could be the reason why the body condition is lower in disturbed habitats. Other than body condition, we also measure the morphological measurements like snout to end length, head width, head length, trunk length, tail length, etc. And we compare the morphological variables of the males between the habitats, and it was found that there is no much difference in morphology between the habitats. Every time we encounter a lizard, we used to take the body temperature, substrate temperature, and atmospheric temperature of the lizard using a cytometer. It was found that the body temperature of the lizard in plantations is significantly higher compared to the body temperature of the Shola. And it was also found that the atmospheric temperature, substrate temperature, and the body temperature of the lizard or basket is positively correlated. So it can be said that any changes in the atmospheric temperature can have direct influence on the body temperature of the lizard. So in the future, if there comes any changes in atmospheric temperature due to climate change, the lizard will have to adapt to that situation either by behaviorally or with other methods. We also measure masking habitat risk variables when we encounter lizards. The variables were atmospheric temperature, humidity, canopy cover, perch height, perch surface, height and width of perch tree, substrate temperature, and the body temperature. We have cited the individuals at a height of 7 meters, but most of the individuals in both the habitats were cited from in a perch height 1 meter to 2 meters. And there is also significant difference in perch height between the habitats. The perch height in plantations is higher compared to perch height in solar forest. The perch surface, it shows that in both the habitats, more number of individuals are sighted on the trees. So, and coming to canopy cover, in solar forest, the lizards are using higher canopy cover areas. In plantations, the canopy cover uses from 50 to 70%. This could be because of the availability also, and also maybe to escape from the terrain. Since most of the individuals were found on the trees, we compare the use and availability of the fresh trees available in for the habitat and based on the tree height and tree GPS. And we found that in both the habitats, the use is in proportion to the available. Site initiation distance is the distance between the prey and predator at which the prey flees. So, while So when the result was found at a distance more than 5 meters, we used to do the flight initiation distance measurement. The distance at which the lizard flees is the flight initiation distance. We also measured the environmental variables and also the animal characteristics. We did not find any significant difference in flight initiation distance between the habitats, but we found that the flight initiation distance is negatively correlated with the substrate temperature. This is because when substrate temperature increases, the lizard becomes more active and the speed at which the lizard can flee will increase. And thus, flight initiation distance will decrease and vice versa. So as summary, we have looked in the study. We have looked at all these aspects like casting, habitat use, density, flight initiation distance, body condition, morphology, and control in the modified and unmodified habitat. So these are the major findings of the study. The soil and declinations of structural different habitats. Habitat modification negatively influences its ratio, density, and the body condition of the lizard. Density of the lizard in plantation is influenced by the proximity to solar and the presence of the shade trees. The atmospheric temperature has positive influence on the body temperature of the lizard. The unrelated spiny lizard prefer trees as basking circles. And calculations in distance and substrate temperature are negatively correlated. And we also found that the density of the lizard has decreased over the past 10 years very drastically. Deepak and Australian study that was Deepak and Australian in 2008 found that in plantations, the density of the lizard was 65 liters per hectare, but during the present study, we found only 8.6 liters per hectare. In Koala, it was 55 liters per hectare before 10 years, now it is 27.6 liters per hectare. In plantations, due to management activities, they are cutting down shade trees in higher altitude regions. So that can be one of the reasons why the lizard density has reduced drastically in plantations. And also in Mona and Irrigation National Park, also the tourism and human disturbances has increased over the last few years. And further studies has to be done to find exactly what is the reason for this drastic decline in density. We could not study the movement pattern of the lizard. Only if he had done this study, he could have cleared that the lizard of the shola and the plantation is, if they are moving across the habitat, that can be clear only if you study the movement pattern. And study was conducted only during the breeding season. The body condition of the lizards can be influenced by the can be influenced by the season. So that study has to be done in different seasons. The data collection forms were frustrated in some areas because the terrain was very difficult and was not fully accessible. We also didn't study the food availability and feeding habitat. This is very important. This is an important aspect because it can have direct impact on the body condition. And we also suggest that for escape behavior, lab studies would be more more feasible. And there are also other modified habitats like carbon plantations. So this study can be replicated in this modified habitats like carbon plantations. I'm very thankful to these people for their constant support and help, especially my colleagues, Dr. CMH and Dr. Dr. Abhijit Das and Dr. Deepak Dr. D and Director Registrar and Dean of the Institute, Course Director, Assistant Course Director, and other faculty members of the Institute, Head of Forest Department and KDS2 Foundations for giving me the permissions, and my field assistant, people of Muna, friends, batsmen, and family and friends. Thank you very much.
Questions?
Interesting work. I have asked you these differences that you're talking about. It's a significant difference between results in a particular habitat and show that the temperature has a performed other show that that's possible. In other words, different, I assume statistical difference or you just saying the difference
This statistics.
that big the both the one. But the box scores doesn't show. You have one box with error bars very small. The other one, the error bars are not but they are not within the overall range of the variation in the both are integrated. Yeah.
Variation was high.
But you see, the plantation, the boss, the discuss about within the range of what it is. Yes. It is within the range of what is already observed.
But when it tested, it was strong significant.
What is within the
So we did interest numbers.
test?
The criteria that note that the 99% confidence interval is not proper. What we find that it's most likely to find that there are no overlap.
It's a medium, yeah. Can you hear me?
Yes, sir.
Thanks for very best.
study by Deepak Givakar, which was done, I think, 20 years back, and on the same Salia species. So, in there is a reverse trend. You see, the plantation shows 65, and then while the Shona shows 55. But in your study, other way around. Right? Of course, there is consistency to kind of the numbers of decline, but why do you think then there's some other thing, or more or less, I would say, earlier more or less the numbers were almost similar. So, any explanation for that, or any sort of speculation on that part?
This is one thing. We found that the lizard is only present in plantations with shade trees. But now, due to as part of management activities, the plantation they are cutting down the shade trees in high altitude regions where this lizard was found. So, in recent times when I went there, in only very few areas we could find plantations with shade trees. So that could be one of the reasons. And also, in the previous study, the sample size, the number of transects was less in plantations compared to solar forest. So,
Okay. The other question really that I had was in terms of flight distance. I was just wondering, I don't know much about the species, but I would assume that what sort of, if you look at what predators there in these two systems,
so recycle.
in terms of the flight distance that you sort of calculate, if you look at difference in any predators that are possible potential predators of Saria species, both these sort of systems. And what do you think their role of that also in terms of that?
We actually didn't have any sighting of any animal feeding on the lizard, but there were large raptors flying over the plantations and solar forest. And we also observed when the raptor was flying over the lizard was showing alert behavior. And we also saw large-scale hippos, which was common in that solar forest. So potentially these two, the raptors and the large-scale hippos could be the predators.
Ajita, very neat and clean study. I just have one suggestion. The 10 years decline. So what you can do is, if you can just get a 10-year-old satellite imagery of sentinel data which is a 1 meter resolution, and just try to count out the change detection in terms of the number of hits which has reduced over these 10 years, then probably you have a much better conclusion to say why there is so much decline. And decline is very much sharp in plantations as compared to shoulder forest. So I think that will be a very nice way of taking your study forward and publishing it. So that will be very interesting.
Why initiation distance? Why did you not do this? What is the reason behind it? Because compared to solar forest, the declinations, the canopy was more open. So it captures were the predators, and also the sorry, it captures were the predators. The frequency of encounter with the raptors will be high in plantations, and also there are humans presence in the plantations. So the result in the plantations will be more alert. It's based on new approach to the approach to the so that's a kind of say that initiation distance data that you are collecting. It's basically yes. So we measured continuous distance only if the first height of the lizard was maximum 2 meters from the ground level. My height.
Other question that I have is with regard to the density estimates that you had earlier. Right? In your earlier slide, you had shown that the depictions of female birds were less as compared to males.
Yes.
Okay. Now, there could be other factors that you not be able to depict here. Maybe they're generally shallow, they're not as visible as the males. Is that the case with the become study? Because if they had actually observed more females in their data as compared to yours, then the density estimate would be so in your it never talked about what's the sex ratio that they have encountered.
In that paper, they have mentioned about sex ratio, but we both use the same methodology, line transit methods, in almost similar landscape.
So is it the same site?
Yes, almost same size.
Okay, and what was the sex ratio there in their study?
They didn't calculate sex ratio in that study. So, yes, sir.
The approach should have been completely different. In terms of it should have been approached in a very different way. Maybe an experimental approach where even height of the investigator can change the inference. There are aerial graders. So all these things maybe if you had an experimental approach or having recoils and testing them before, maybe you would have needed more better results. So just a comment.
Yes, sir. Actually, one problem with this continuous system was that we usually not encounter the lizard when we become very close to the lizard. So we could not measure the continuation distance for larger sample. So very good morning to one and all present here. Today I'll be talking to you about 12 networks. So these felines are the most widely distributed of all wildcat species globally, and they are found occupying almost all areas more or less throughout within the country, except with the exception of desert area and the mangrove areas of the Sundarban. However, across several parts of Asia, as well as in India, they occur sympatrically with tigers and are dominated by their striped counterparts due to differences in body size. This renders the two felines unequal competitors. and there is establishment of a clear dominance hierarchy between the two, with tigers exerting top-down control over their less dominant counterparts, the leopards. However, leopards being hypercarnivores do show favorable responses in the spatial control patterns in addition to competition and dominance. This forms the basis for the bottom of control. Therefore, there is a neat balance between avoiding competition as well as seeking prey for leopards, and there will be messes between these two in an ecosystem. Several studies have been conducted over the years across various landscapes in order to understand the effect of the responses of leopards to the presence of tigers. Numerical responses have been studied in landscapes such as in Sariska and in Biodiversity National Park, amongst other studies. Dietary responses have been studied across Nagarhole, Bandipur, as well as in Mudumalai over the years. And behavioral responses, which is a combination of mostly the spatial, temporal, as well as the dietary niche axis, have been also studied across various landscapes, including Manas National Park, the southern West Ghats, Sariska, and Mudumalai, amongst other studies. A vast spectrum of responses have been observed along the spatial and temporal niche axis to leopards in response to tigers, ranging all the way from clear segregation seen in Sariska post the introduction of tigers, as opposed to almost virtually no segregation in the spatial and temporal axis in Mudumalai. And this is what led to my curiosity and my study title, Spatial and Temporal Responses of Leopards in the Presence of Tiger in Biology National Park in Uttarakhand. As suggested by the title, my study was conducted in Biology National Park. The ranges of Golfman, Bedipara, and Haridwar were sampled in Western Rajasthan, while those of Chilla and Ravasant were sampled in Eastern Rajasthan, all falling within the core area of the national park. This national park and landscape serves as an excellent ecological setup for addressing the question of responses of leopards to tigers, as Western Rajasthan hosts only a resident population of tigers, and thus serves as a control setup for my study, whereas Eastern Rajasthan shows impacted occurrence of both tigers and leopards in the landscape. My objectives were to evaluate spatial niche segregation between leopard and tiger in Eastern Rajasthan National Park. And the specific question I asked was, do leopards segregate from tigers in terms of their space use? My second objective was to evaluate temporal niche selection of leopards in the presence and absence of tigers. And my specific questions were, does the temporal activity pattern of leopards differ from that of tigers in Eastern Rajasthan? And does the temporal activity pattern of leopards differ in the presence and absence of tigers? I hypothesized that the presence of a dominant predator, that is the tiger, will influence the niche selection of a less dominant predator, that is the leopard. And this will manifest itself along the spatial and or the temporal niche axis. Hence, leopards are expected to segregate with tigers in terms of space use and temporal activity, and alternatively, in the absence of tigers, leopard space use and activity will be determined by that of the prey. In order to achieve these objectives, information on leopards, co-predators, and prey was collected using camera trapping. Sampling ranges were divided into 2 kilometers by 2 kilometer grids, and a single camera trap was deployed in each of these grids. The location and placement of cameras was decided based on the presence of leopard and tiger signs, and cameras were placed around trails, forest roads, water holes, and grounds to maximize capture of the target species as well as prey. Data was additionally also recorded for the data deployment, the camera ID, as well as the GPS locations for the cameras. Here is a map depicting the camera trap locations for the deployed camera traps, as represented by the black dots. A total of 39 camera traps over an area of 136 square kilometers were deployed in Western Rajasthan, whereas 32 camera traps covering an area of 132 square kilometers were deployed in the eastern part of the park. The cameras in Western Rajasthan were operational on an average for 33 days, and a total of 1326 trapping nights were recorded. In Eastern Rajasthan, 38 days was the average duration of function for a camera trap, and 1,222 trapping days were recorded. In a snapshot, about 5,000 independent captures of around 28 mammalian species were recorded from Western Rajasthan, whereas 677 independent captures of 27 mammalian species were recorded in the eastern part of the park. There was a stark difference in the number of independent captures in leopards across the two regions, with about 328 independent leopard captures in Western Rajasthan and only 27 leopard captures recorded in the eastern part. There were a high number of tiger captures, with 233 independent tiger captures recorded in Eastern Rajasthan. Some common species found throughout the landscape were barking deer, cheetah, sambar, white-tail, porcupine, small Indian civet, lemur, and macaque, to name a few. The events are exclusively recorded only in Western biology, and hyena, black bear, and stork bear are seen only in the eastern part of the park. Cattle, in few numbers, were recorded across the park, and the occasional capture of feathered dogging catbirds. In order to analyze my patterns in space, I sorted the camera trap images up to the level of the species. Record tables were generated using camera R. Relative abundance indices were calculated as the number of independent captures divided by the trap days. The predator and prey relationships were explored using box plots. Occupancy for leopards was also modeled using presence, and occupancy maps were generated. Activity hotspot maps were also used. It was observed that with low tiger RAI values, the RAI for leopards is also low. However, this may be possible due to these camera traps being located in areas with low availability of prey, and hence this serves as an artifact in observation of this particular pattern. As prey availability increases, the RAI for both the predators increase, as is seen by shift in the medians. However, as target RAI increased from the moderate to the high categories, a drop in the median value of leopard RAIs was observed. This is also evidenced by the scatter plot here, where the leopard RAI declines with increase in the tiger RAI and may be indicative of avoidance. Influence of prey on the two predators is also analyzed, and it is seen that for preferred prey, as well as for all prey species, there was an increasing trend in the RAI of leopards with increase in prey RAIs. However, no clear decipherable trend could be seen for tigers, and this could be due to camera trapping being conducted within the core area of the park, and there is availability of sufficient prey or high abundances of prey, and hence no clear trends were observed. The occupancy of leopards was also modeled using prey and tigers as covariates. The best model resulted from tiger RAI influencing the occupancy of leopards negatively. Upon removal of the outlying point, a clear trend was seen where leopard occupancy was negatively affected by the RAI of tigers, hence also indicative of avoidance in space use. Here is a map showing grid-wise leopard occupancy across the sampling area. The occupancy in western biology is high and uniform, which is in the treatment of absence of tigers, whereas in eastern biology, the occupancy depends based on the presence of and the spaces of tigers. Activity hotspots were also generated for the predators, and it was seen that in eastern biology, the tiger hotspots were centered towards the core, while those of the leopards were located towards the periphery of the park. Segregation was also observed in the hotspots of tigers and leopards, with the red hotter regions in the map representing more exclusivity of leopards in these areas, while the bluer colder regions represent exclusivity of tigers, and regions of intermediate colors, such as the ones indicated in the circles, represent areas of spatial overlap. In order to understand what might result in these spatial overlaps, prey hotspots were also generated. It was found that the regions of overlap between the two predators may be explained by availability of higher prey, and hence regions of coexistence may be attributable to prey availability, at least in part. Leopard hotspots in Western biology were also generated, and it was found that they occupied more or less the entire landscape where the camera traps were deployed, as did the prey. And hence leopards maximize utilization of space in the absence of a more dominant predator. In order to look at my patterns in time, temporal activity curves and overlap coefficients were estimated using the package overlap. Bar plots were constructed to compare predator and prey overlap coefficients, and lag times were calculated between tiger and following leopard visits, and box plots were constructed. Temporal overlaps among predators reveal some interesting patterns in my study. So here is an overlap curve of leopards in Western biology and those in Eastern biology. The activity of leopards in Western biology, as indicated by the black curve, showed activity spread pretty much throughout the day, whereas that in Eastern biology were concentrated during the morning and evening hours and showed higher intensity of activity during these times with very little activity during the day. Now, could this activity be dictated by presence of tigers? Contrary to what was expected, it was found that these elevated two leopard populations coincided with the activity patterns of tigers in eastern biology. And the only slight difference observed was in the smaller secondary activity peak, which was temporally distinct from that of tigers in eastern Additionally, the overlap between tigers in eastern biology and the leopards in western biology was also seen. It was found that in the absence of a more dominant predator, leopards in western biology show patterns similar to an otherwise apex predator, such as the tiger in eastern biology. This, however, still leaves the question of why there are high temporal overlaps between tigers and leopards in eastern biology unanswered. And to look into that, great temporal patterns were also analyzed. It was found that the overlaps of leopards and prey species in western and eastern biology differed for cheetal, sambar, and whitetail in terms of the value of the overlap coefficients. However, the activity patterns only differed for sambar between the two sampling sites, with sambar in western biology being active throughout the day as indicated by the red line, and that in eastern biology showing activity concentrated during the morning and the evening hours. Hence, to reconcile the differences in overlap patterns for certain prey species and then differences for others, preferred prey were tuned, and it was found that the overlap for prey in eastern and western biology were different, and so were the activity patterns, with prey in western biology being active throughout the day, whereas in eastern biology showing distinct activity during the morning and the evening. In western biology, leopards and prey showed activity spread pretty much throughout the day, and they were in tandem with each other as would be expected. In eastern biology, the tiger and prey showed overlaps during the morning and evening hours in accordance with the activity patterns of the predator and the prey respectively. Leopards, however, they showed a region of overlap in the evening hours, which is pretty identical to that shown by tigers and the prey, as the activity patterns of the two predators are identical in this part of the day. The slight difference was observed with the smaller secondary peak of leopards, which showed overlaps with high activity of prey and during the same part of the day. So for this smaller secondary peak is a sort of a win-win situation in the sense that this is the part which segregates from tigers in terms of temporal activity and also overlaps with prey. However, the question of the two higher peaks overlapping with tigers still remains. It was subsequently observed that visitation of tigers at camera traps was staggered from the visits of leopards at the same camera traps. And except for two occasions where they were captured at the same camera trapping location on the same days, there was a clear lag observed between leopard visits following tiger visits at the same camera trap. This lag time was calculated and it was seen that at low values of tiger RAI, the lag times were high, and this may be an artifact of low abundance at these camera trapping locations. As the value of tiger RAI went from the moderate to the high category, though the value of the median lag times declined, there may be an underlying increasing trend. There are more values above the median in the higher category, but this might be marred by and confounded by lower captures of tiger, and more captures would be required to establish a clearer trend. However, this does not take away from the fact that there was lag between leopard visits following tiger visits at camera trapping locations, and they were staggered to their visits. Hence, the major conclusions from my study are leopard occupancy of space use is negatively affected by the relative abundance of tigers and is indicative of avoidance. There is segregation in leopard and tiger activity hotspots, and the region of coexistence may be explained in part, at least, by the availability of prey. Leopards are unable to make use of the entire available space as they do in western biology in the absence of a more dominant predator. There are differences in temporal patterns of leopards in western and eastern biology, and this may be attributable partly to prey and partly to the presence of a dominant predator. High overlaps are seen between tiger and leopards in eastern biology, that is in the area of sympatric occurrence, and this may be explained in part by the activity patterns of prey. However, in regions where there is spatial overlap, and also given the high temporal overlaps, segregation might be occurring at a much finer scale and may be a combination of spatial and temporal components. As the two species were not recorded at the same place at the same time, and there was a lag between tiger and following leopard visits. Some of the caveats in my study were that there were only limited number of leopard captures from eastern biology, and hence relative abundance in contribution. And thank you to all of you for being here and for the patient listening. Thank you very much.
Can you hear me? So I was just curious whether you had differences in sex ratios of leopard captures as well from the four eastern randomly where tigers are there. Whether you had differences in sex ratios of leopards captured as well. Is that something that you looked into?
So one was something I did not really look into, but I only had very few captures to begin with. I don't know other methods that I really.
And the second question I wanted to ask was the attraction avoidance ratio which you did at the end at the final scale, the lag between pictures. Did you also look at the delta value between consecutive leopard captures to see if it's different from leopard and tiger?
Reduce the data value.
The time difference between.
Okay, so I did calculate individual lag times for each of those videos, and this was the trend that I observed. But since I had very few number of captures in terms of leopard versus foreign tiger, this I really could not get a very clear trend in terms of how that lag time is changing. However, there was definitely a lag in the
My suggestion was to also look at consecutive leopard images to see if that is different from what you got between leopard and tiger, but maybe with more captures. Have a look at it. Okay, thank you.
That's a good answer. So, what I think see for the system industry.
So, sir, yes, so obviously the camera trapping was done from late February to the end of March, and then in Eastern Malaysia it was done in the month of April and at the beginning of May.
So, when we are doing the presentation, the other one is the good size of the records. So, today we started with the I think one of the major issues is with respect to the good size when we talk about the special quantities and disease. For that means 2 by 2 goes a very big good size. So, it's a lot of numbers. So, that you consolidate the groups. So, so we will software. Question from Rishi asks, how is the presence of leopards in that area benefiting the tigers of that region?
So, sir, I really cannot visualize leopards benefiting tigers. It's sort of it's an area which has been historically occupied by boats, and my study aimed at understanding how these patterns of spatial and temporal skill efforts may change in the presence of absence of